So here we go. On page 13, page 13, that's where we kind of ended the lesson yesterday. If you have three sides but no angle whatsoever, you have to use cosine law. That's your only way out, right? Your only tool out of that hole, basically. And I always focus, like, if you pick the three sides, you have to pick the one that's across the longest side, right? So that's very important. How about we write that down on page 13, that this is the longest side. This is page 13, and here I'm going to give you a little conclusion here. Note, cosine of a negative will always give you, right, returns an obtuse angle. Greater than 90. 90 is like your measure, okay? I'm going to box this in with a highlighter yet. If you have cosine of 0, like, sorry, I should say this, make sure you go inverse. Inverse, right? Cosine of 0, inverse of 0, returns a right angle, right? So it's 90 degrees. Grab your calculators real quick. Let's just make sure we understand that. If you go shift cosine, right? If you're trying to do the inverse of a negative number, so negative 0.5, let's say, negative 0.5, you get an obtuse angle. It's 120 degrees in this case. If you go, let's go shift cosine, and you happen to get 0, like you plug in a bunch of stuff and you get 0, the inverse of 0 is 90, exactly 90 degrees. If you go shift cos, like the inverse of any other decimal, so 0.25, let's say, positive, then you get, in this case, it's 75 degrees, right? 75.52, so it's less than 90. So cosine law has three options, basically. Cosine inverse of positive returns an acute angle less than 90. Okay. So I'm going to highlight that part. Got it? Okay. This one down here, by the way, this is one of the questions that was on this AC just right now. Okay. So look at it. It's like, hey, classify this. Don't guess. You have numbers. If I didn't give you numbers, if all I give you is a diagram with some markings, it's a different story. But you've got what? You've got angle, and so because you can't positively conclude that this is acute. We don't know. This up here could possibly be an obtuse angle. We don't know that. But we have a pair, and we have this side that allows us to find that angle. And was this the exact same question? No, I think it was different numbers on the AC. Okay, I put the key on yesterday's video. It's up there. Okay, so you can try that one. Let's go to 14 here real quick. 14. If I asked you to classify, can you posit it? Can you just guess in this case? You shouldn't, because you have numbers. So can I use Pythagorean theorem? No, there's no 90-degree angle. So no guarantee, right? So do not use Pythagorean theorem. But what can I use instead here? Anybody remember? So what is that? Which law? Cosine law. You could find this side using cosine law. If this side turns out to be 1.9, let's say, then you have an isosceles triangle, right? If this turns out to be anything but, like let's say this is bigger than the two, then it's a scalene. So you're narrowing it down. Okay. And I would argue you would still have to find. Should I do this one with you? Do you want me to do this with you? Yes? Yeah. Okay, I'll do this with you. Due to popular demand, I will solve this. Okay. So let's figure that one out. X squared is equal to, you take those two sides, square them, and you go minus 2 times the first one times the second one times cosine of the only angle that you have there. You go ahead and type this in, right? I don't know if you remember how to do this. I saw some interesting stuff when this is on the exam. Students come up with something like, I never taught it this way. But sometimes you freeze, right? So practice makes perfect, or almost perfect. How's that? Practice makes better. Let's just go with that. I get that number, 4.90, and I want you to use all decimals if you want to get full marks. Sometimes rounding too soon results in a different answer. I take the root of that. It's 2.21. And what are we in? Meters? Okay, 2.21, let's write that in. Can I stop here? Can I now make my classification? I would like to hear your input. But, oh, my bad. I won't do that to you in this unit. Good call, good catch. It's just meters. That just butchered it, eh? Just meters. Sorry about that. Can you make a conclusion here? Janelle, you saying yes? How come? They're all different sides, so I can actually make a conclusion, right? Scalene. Okay, you are right. That one I would give you for sure. What about the other one? This is acute, right? Or it is acute. I would give you that. But why is it? I just want you to know, I don't know, sometimes I draw conclusions and just move on. Out of all the three numbers, which one is the biggest side, the longest side? This one, right? Slightly. So this is the longest side. Which will make this the large, not all at once. Hold it. Largest angle, correct? Is it possible that any other angle is bigger than 67? Say no. Not possible. Because this is the longest side, this is the largest angle. So there's no way that I have a 90 out there. There's no way that I have an obtuse angle out there. Just no way. So we're done. Acute, you are right. Acute scalene. And I will guide you like on a test, like I'll say, find this, find that, usually. And then I say, okay, now classify. But this is the reasoning. Should I say that there? Since 67 is across the longest side, there can't be a larger angle present. In this case, you're restricted to 67 or less. Right? You're restricted to 67 degrees or less. I want you to do the next one before I move on to quadrilaterals here. What would you do in that case if you do this one down here? We did this on the AC. There's one angle you need to check. We know this is scalene. I hope you see that this is scalene. But is it acute? Is it right? Or is it obtuse? Which angle would you check for? B, right? B, because it's across the longest side. Mr. Dirksen, could I check all of them? Could I do cosine law and just check them all? If you like to do work, you go for it. But I don't like to do a lot of work. I like to do like the bare minimum. Okay? So I will check this one. Can you check B? It's going to be interesting. Your results are going to be interesting. Okay? What do you need? Pencil? Find B and see what you get there. Longest side. So I'm going to check this one. Check. Okay, so go for it. Use cosine law to check for that one. What do you get? Okay, it's better to. Oh. Okay, cosine of B. This actually ends pretty quick. You get 0 at the top. You're supposed to at least. I think that was my intention there. Yeah, you get 0. 0 up top, and then actually that's the end of the story because it's 600 at the bottom, but really it's going to turn into 0. Any like 0 divided by anything, 0 divided by 600 is still 0. Right? So B is cosine inverse of 0. Angle B is 90 degrees. Okay. So this is a right because of that scaling, because of obviously all the numbers are different, right? So it's a right scalene triangle. Anybody remember how else to check if a triangle is a right triangle? You remember in grade 9, like Pythagorean theorem, they would say take this one, square that one, and then square this, and add. If both sides are equal, then it's also a right triangle. You can also do that if you want to check for right triangle, but I'm just going to stick with this because it forces you to review cosine law. All right. I'm going to stop. We're going to pause with triangles for a little bit. There's more you can tell. Like if you flip through it, there's tons that you can still practice and work through. And to be honest, you should be able to figure out triangles if you just break them down and use the tools you have. The bridge here is going to be interesting. I'm going to do that with you. It's actually pretty cool to do that one. So let's keep going though, all the way to 25. And I'm going to make a separate video on this because this is quadrilaterals. So we're going to write down a bunch of stuff, and then tomorrow we'll actually work with them. Okay.